It's a really exciting time. I got my electromag rotor working quite nicely now. It's working on a reed switch, a 12-volt battery, 2 drive coils, and 4 pickup coils. Right now the pickup coils are just added weight, which is okay. Awesome. Hello. How's it going, everybody? I'm just going to let that run. Hell yeah, thank you. Hello, hello. Yeah, that is a triumph of ingenuity of a rudimentary style. Or you could call it lack of style, but I like to think it's stylish in some kind of way. Hell yeah, reminds me of some sort of punkish thing. I don't know, man, just outlandish, maybe apocalyptic. Check it out. Hell yeah. So there's nothing going on here except what I mean is I'm going to take the camera off the tripod in a little bit and show everybody there's nothing going on underneath the table or anywhere else. It's all right there. And basically all you need is that 10 millimeter shaft and it can go anywhere. And 2 magnets of varying sizes. So you need a big one to hit the switch on one side, and then you need a smaller one to hit the coil on the other side. So they're in series, but the switch is only being hit on one side. So it's timed perfectly because I'm not using 2 switches. And it's smooth. So the 2 drive coils are in series right now. I had them in parallel a little while ago, and it's very choppy in parallel. Very choppy because the magnets hit Well, if I did it like this, it might work. So I'll be able to check it out. Because the big magnets would hit the switches, and one would always end up burning out. And it would go back and forth. But this kind of solved the problem, having the varying magnet sizes. Hello, hello. Guts, what's up, my man? Sorry, I'm not viewing the phone right now. It's in the tripod. So I'm going back and forth as often as I can, you know. And the way I have it set up right now, it's on a 12-volt battery pack, and but it's in series coil series, so it's going to spend less energy. I mean, it's going to draw less amps because there's more resistance. That's kind of what I'm saying. And I don't know, man. We'll see how far a battery pack will go. That's so cool, man. I was fiddling with it. I'm like, I know what I got to do. I got to put it in series so it hits on the 180. And then I got to get a magnet involved that's not going to trigger the switch. Because the switch is in the middle in here. And this magnet is triggering it from where it's at. And then I got a smaller magnet on the 180 that won't trigger it, but will interact with the coil on the 180. So you get that little extra burst the way it's supposed to be. Then it ends up being the way it's supposed to be. And then you just do this again on the other 180 right here, and you don't need to add any coils or anything like that. And you get double the impact. It's because the orientation of the switch has to be across the magnet. So when the magnet has to be orientated like this way for it to affect. So it'll work having the other 180 there, and it won't frick it up like it did having the two big magnets on the 180. It's kind of hard to understand because I lack the maybe not the vocabulary, but the way to put it together so it makes sense. Or maybe it does make sense. I just found it really fascinating how all of a sudden I figured out how to put it together. This isn't perpetual motion, you freak. But it is a pretty ingenuitive way to look at a pulse motor, for sure. I don't see many pulse motors with the electromags on the rotor. And I see drones like that. I've seen a drone built this way. Oh, I don't care, dude. There's no way you're hooking up a meter to that thing. You're out of your mind. Just use your brain for a freaking second. There's no way. I mean, you could hook a commutator plate, but you're not going to get a solid reading off of it. And sorry, I said it was a pulse motor. It's more of a toy that I like to, maybe it's a time machine. There's no readings. You're not going to get a freaking reading off of this unless it's like the meters on the wheel. And I don't have a meter that small. I don't think anybody has a meter like that. That's why I don't have any readings, because there is nothing to read this. Anyway, I still think it's cool, even though there aren't any readings. I'm gonna let it spin till something falls off. Sure, if that's where your mind goes, pole dancing robot is what it is then. Man, there are so many things I'd like to say, but the right words just don't come my way. Yeah, man, that's good. That is solid, smooth. I mean, it's probably going about 200, maybe 200 RPMs, 250, maybe. Nah, it's not 250. No, it is a brushless motor, yes, but it's not. Yes, actually, very much so a DC brushless motor inverted, I guess. So that's the elect. You know how the stator is usually made up of electromagnets, right? And they don't move. They're pretty just solid. They're sitting there. The stiller they are, the better your motor will be, basically. And this is that in reverse. So you got the stator magnets are permanent magnets, and the electromagnets are the ones that are moving. So you get a totally different signature. Like if you were to read the air around like a pulse motor normal and this pulse motor, totally different structure around this motor. It's really neat. So I'm thinking now about how I could like make more, pulses, and maybe have them be sequential pulses. So it goes doot 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 instead of like a bunch of them going doot all at once. That would be pretty cool. And then if you see that happening over and over again in a circular motion, I mean, there's your spiral right there. Yeah, stator stationary. Thanks, buddy. I'm glad you're helping me out there. It kind of feels like you're not helping me, but that's okay. You're right. The stationary, uh, either electromagnets or permanent magnets. And I make them where the stator moves too. So it's basically like two rotors and they counter rotate. So that's another one I do. See, here's a rotor for one of them. And then the other rotor sits in the middle here and it'll spin this way and this one will spin the other way. It's pretty neat. This was the first one I built. And it has a cap on it and everything, man. It was great. I have a video about it. I have a live stream about it. You can check that out if you'd like. Like, subscribe, hit the notification bell, join up. We do really like outlandish stuff here, but we don't do it in the name of free energy. Okay, none of this stuff is free. All right. I mean, you could say that the sun, the solar energy is free, but I mean, even there, I'd love to hook this up to a solar panel, not this one, but the SSG where you see this transistor right here? It's hooked up to a coil, this coil right here. And I got another rotor under the table. So when this dies out, I got an SSG hookup. You can see the two batteries for it right there. But what's going on right now is definitely not SSG. Hell yeah. Oh, Yanni, I was thinking about making a better coil for my Bedini setup for the SSG. It's slowing down. We might have blown the switch. I'm not sure what's going on. Yeah, it looks like a blown switch. See, when the switch sticks, it stops. All right, so that was an awesome run. I'll tell you what, these reed switches are kind of finicky though. Hell yeah. So let me take it off the tripod real quick and show you, give you a close-up of what it's all about. And why it may have taken so long to get this to line up with the stator correctly, but I finally did it. All right, you got your two batteries. There's a battery underneath here, and there's a battery over here. That's for balance. You can hook them up 24 volts. You can hook it up 12 volts. You can hook it up parallel. See, there's two drive coils. One right here on the tip, and one right here on the tip at 180. So, and then the reed switch is right there, like I was playing with it earlier. And when that triggers right here, and the drive coils are hooked up in series. So when the switch hits, it hits on both sides. You got this little magnet over here. And that's nice and smooth. You got your cap bank and your rectifiers and all that hooked up. One for each battery, and you hook the battery into the one side, and any pickup coils you want to hook up go into that side as well. And then the other side, it comes out the other side and hooks to the reed switch and the coils. Awesome. It's something like that. I wouldn't necessarily call it a pulse motor. It's an electromagnetic rotor. Because you're not going to get any readings off this. There's no way to get readings off of it. You could make a plate of copper underneath and have brushes touching it, but you're not going to get a crisp reading like that. It keeps me from doing dumb stuff. That's enough for me. Reed switch, hell yeah. Um, a buddy of mine told me that this could be like a time machine mechanism, like an OTC um, X1 type thing. I'm gonna start it as soon as I get another reed switch. The reed switch is blown, so I need to change that. I need both my hands to do that. So I'll do that in just a second. No, I don't know. It's not a flux capacitor. OTCX1. Is reminiscent of, not exactly like. Because his machine used Utrons and Tunians and was like a marvel of ingenuity when you think about it. All right, let me get the switch. Man, these things go so fast because there's no bifilar really. There's no when you put resistance on the main line, there's no point to do that. There's no point at all. Except to save your switch, but it won't even run. You need to get it like a 50 ohm or less. $12 volts. 180 coils. Hell yeah. All right. Now let me get you off the tripod. Yeah, I thought about that. That's a whole nother setup though. There's no transistors on this thing, dude. This is raw electric, straight connection. There are no transistors on this at all. It's just a reed switch, a battery, and 2 coils. Well, when the electricity in the switch, okay, the switch passes the permanent magnets, and then the power goes through the coils, sends a pulse, and as the switch moves past the magnet, it'll open up again, and the pulse will stop. That's how it works. It pulses. And when it pulses on the magnet, it pushes. So there you go. Hell yeah, man. They know a lot about this stuff in Africa, man. You could definitely probably do that. Don't be a moron, though. You sound like a frickin' fart in the wind, bro. Man, then F1. You sound like a fart in the wind. That we might be able to find out. I'm thinking it's going right around 250 right now, the way it's set up. Maybe more, maybe like 400 actually. Maybe 350. I don't know where it's at. Man, we're just playing with it too. Let me look. I'm looking for my tack meter. But we don't have a tack strip, so it doesn't really matter. This is the fastest it's gone consecutively ever since it's been made. Because I figured out how to make it. You know, where to put the magnets and how to set it up so that it wouldn't hit, the switch wouldn't hit on both sides. That's real important, that the switch not hit. Well, that's not true. I was working with two switches, and I've got another magnet like this, and I had that on the other side. I mean, just touching this, you can feel it pulse. It's pushing like hard. And then there's a little Neo over here doing the same thing. But it's not triggering the switch, so you don't get that double hit that screws everything up. But as soon as I'm done with this, I'm going to hook back up the SSG and we'll get some readings and all that good stuff. That looks so cool, man. We're going to get the aerial view. I got to get you guys an aerial view. Woo! Man, that looks so cool. See what I mean, man? Dude. Full ceramics. Full ceramic bearings. Yeah, these are the best you can get, I'm pretty sure. Next to the hybrid ones that I have for my other one. They got the cage on them, though. That's what makes these a little bit slower, I think. Oh, are they like red? They're called red or something like that? Yeah, those the skateboard bearings are really, really good. But these are just full ceramics. So cool, though. And I have it built so it can go like probably twice this fast right now. I can hook up the two batteries in series. But I'll probably blow the switch doing that. This right here, I can't answer that. It is an experiment currently. Might end up on the shelf somewhere as a toy if I minimize it. Yeah, I was going to find that out. I was going to put another big one here and another little one over here. or whatever wherever I put them, they got to be 180. I haven't added them yet, but we are definitely going to try that out. Because you got to have one to trigger the switch, and you got to have just like the same setup as right here. But and I don't know about getting them close to each other. And then I have to move the batteries out of the way. I can do that though. Wow, man. As long as the reed switch holds out, that'll work. And I guess there is definitely a way, the way it's currently set up, that I could put a breadboard on there and actually use a Hall effect. Because there's no way I don't solder. I don't solder. I mean, I could probably, if I sat down and maybe was taught how to do it, like what I needed to make it actually work. You can't just assume that all those tools are common knowledge. I mean, they are like available to the public, but that doesn't mean it's common knowledge. Actually, I don't know. I don't think these are attracting. Hello? I have an Arduino, but I don't know how to use it. I need to learn that too. Hello, hello. Thank you. Appreciate it. Um, yeah, my buddy Hall Effect X, man, he's the one who said, you get the magnet, the electromags to be the things that are spinning, and that's the first step to making a time machine right there. That's the internal mechanism of a time machine. And it's because of the way when the electromagnetic, it's pulsing and it's spinning. And that's what makes it happen. The permanent magnets don't pulse, so you don't get the same effect. Oh, I think our reed switch burnt out. Yeah, I saw it. Like, did you see it turn orangish? Yeah, that's it right there. Narrowed it down so that each side, all you got to do to turn it on is plug this wire into the socket. Um, I could do a switch, but that's just more wires. That's just more. I'm not trying to put any more on here. I'm pretty sure it's not spending very much of the battery juice because each drive coil is a bifilar coil that is 20 gauge and 28 gauge, 200 turns a piece, so that's 400, 800 turns of wire on a bobbin this size, granted, and then it's limited to 28 current. So that's awesome. That is truly amazing. Yeah, I don't think this thing's gonna take off though. It might. I don't have any idea. Yanni, awesome, man. Oh no. Yeah, personally, I don't know that much about gravity. I would suggest checking out Old Man Builds. He knows a lot about the anti-gravity flyer, and he would be able to answer any questions you have about gravity, I'm pretty sure. But yes, I think gravity and time are very interconnected. So I would assume, but that would be an assumption. All right, now I got it narrowed down to the one switch. I'm going to try using a smaller reed switch. I got a bunch of those. It may or may not work. We will find out in just a second. They're gilded too, so they got some gold on them. But they're like half the size of the one I was just using. All right. All right, sweet. I don't know how long it'll last for, but I got tons of these. I have tons of these. Man, this will last. So cool. Wow, they look maybe like they're doing better than the big ones. Look at that. Look at that. Wow, man, that is a new record. Woo! Where I need to find my tack meter. Oh my god. Oh, I found it. I don't think I'm gonna be able to get a reading though. That's the thing. Then we'll set up a strip on there. Yeah, I'm not gonna get a reading off that. Not without some tinfoil. Yeah, wow, man, that thing is cranking. That's not right. It says, I mean, it says it's over 1,000. That's not right. All right, I'm gonna get some tin foil real quick, and we'll get some speed readings on that. And I'm not gonna be like, I don't have any glue left, so I gotta be able to buy glue before I can continue. Maybe I got it. I don't know, man. It's on tin. It's on the duct tape, so I think it's interfering with crisp reading. It says it's going over 1,000. $800. $238. That sounds about right. I don't know. It's not gonna be. There's nowhere to put it. Wow. So neat. Man, that's exciting. Should we try 24 volts? Huh. Yeah, you can't hook a meter up to this. There's no way. It would immediately stop moving if you tried to hook a meter up to it. So neat. All right, we're losing something. Hold on. Yeah, I think I gotta glue something down real quick. And see, I got the resistor right there. I was trying to use resistance. It just wouldn't work. Wow, man. Dude. Maybe I should make a stator that'll move. Miss one. Only running this thing will actually tell whether I got it all. Yeah, we're going to add the other magnets. We're going to see how that'll work. We're going to see if this reed switch can handle it. So we need the magnet detector. We're going north in. All right. Got to do something first. Demolition. Got to get the glue off here so we got a surface to work with. All right, this is it. All right. Yep, we're gonna do it. I just gotta get one more magnet in place. I don't know if this will work. I don't know. I know the 2 work. I don't know if 4 is gonna work. That's a lot of magnetism on the switch. And this is it. That's the last of my glue right there. Yeah, it's too much. Because they're so strong. Yeah, it's way too much magnetism. And there will be no more gluing for now. Which kind of sucks. All right, let's switch out the blown switch. Maybe it isn't blown. So cool. There was a bad connect right there. Damn. I'm not going to hold it there. Maybe I will hold it for a second. Because the problem wasn't with the switch that time, it was with the connection. So definitely slowing down. I do feel it though. I think what's going to happen is if I put more coils in there, then we can work that. But it isn't going to work any other way. All right. All right, taking this off. I'm going to catch up real quick. Hell yeah, man. Look at all the reed switches I've blown. I got tons though. I got tons more. These little baby ones are rocking it, man. They're so cool. I didn't think the little ones would be so nice, but this is a little one right here. The gilded switch, and it's got gold on the. So I'd say that's working rather nicely. So what I will do is I'll build 2 more drive coils and I'll put them on the other 180, and that's how we're gonna. I don't even know if that'll work. You'll need 2 switches. It'll work. It'll work because they'll be independent of each other. Maybe it won't work. What if they go the different directions? Yeah, yeah, yeah. I was thinking about making and I'm continuing like there's just one small issue. Same issue basically. The reed switches keep blowing out. This is the rotor for that one, and there's the shell. So the rotor goes in that little hole in the middle, and that thing rests on the shaft, and so does this. They both go on the shaft, but and then the rotor's magleved, so it's kind of floating in there. Now I was getting the bearings out of this, and it broke because it's like light infill, so that's not good. I gotta get the toroid off that. Now that is garbage. Okay, when you break something and then you can't use it anymore, you gotta throw it away. I just love how, like, it's just running. Took me a while to figure out how to get it to go like that. Now what I see is it being able to be run SSG because you got 2 batteries on there. And then you just slap a small relay and you can swap the batteries on your SSG circuit, and there you go. Awesome. But like, I gotta learn a few more things before I can attempt to do that effectively. One, I gotta learn how to solder to make the connection as small as possible. And maybe that's the only thing I really need to learn how to do. Mm. Well, you can charge the other battery with an SSG on it. It all has to go on this rotor. It can't be on the side. It can't be anywhere except on it. That's how it works. So the power supply, the switching mechanism, and the coils all have to be on the rotor. And no, you're not going to get any readings. There's going to be no room for readings unless you can put a multimeter on there that's small enough to get some readings. But I'm telling you, man, you did like this style thing, you can't use that. You cannot use that to get readings off of this. Thank you very much, everybody, for coming in. I really appreciate you guys deciding to check this out. It's pretty cool, in my opinion. It is an inverse pulse motor. No readings. Like everything you would do with a pulse motor, you don't do here. Just getting it going like this is a marvel of ingenuity. And then to make it so you can get readings off of it would be epic. Like epic ingenuity, dude. Because you got to make a commutator plate on the bottom. Okay, so you got to put a little plate of copper or some sort of conductive metal underneath. And then you got to have brushes hanging off of the connection that you want to get reading off of. And then you got to have a north or positive and a negative plate. And then you got your positive and your negative clip. You got your positive and your negative brush. I'm not going to do that. I have such terrible luck making brushes, dude. I'm not going to do that. Oh, sweet, man. That would be so cool, actually. I don't know where exactly I would, like, put it. But I have 4 pickup coils in here as well that are hooked up to one of the cap banks in there and feed it directly to the reed switch on that one side. So when it gets going fast enough on these Neos, man, those pickup coils are going to generate some power that the reed switch is going to be able to use. I got diode in there and everything, so like they don't get confused, the battery power and the pickup power. Oh, it's got a LED in there. You can kind of see it, the red one. There's 2 of them. But yeah, I know what you mean. Huh. So, in order to get anything off the wheel, you're going to need a commutator of some kind. or wireless. I don't have a wireless antenna on the spinnaker right here. I don't have that, so yeah, that's going to leave it with the commutator plate. Really, all you need is 2 plates and positive and negative brushes to whatever you're trying to make a reading on. But you do realize that then switching it to a different place to get a reading is going to be impossible to do. So you're only going to be able to get one reading. So you should or you can have that deliver electricity out and charge a cap bank or something, do that with it. Hook the pickup coils up to the commutator. Well, this one's smoother than my other rotor. So it's like a lot quieter. I think I got some dust or something. Something's in the bearing and it's making it squeak on my other rotor. So I don't know, man. I don't feel like spending a bunch of money on ceramic bearings if they're gonna get, gunked up. And I'm telling you right now, man, my habits aren't gonna change just for ceramic bearings. I wish sometimes, but I really don't care that much about it. Like how everything that I need is on the table. And when I try and clean it up and put it away, I never know where it is after that. So oh yeah, Yanni, you know what I'm talking about. But we put it away anyway because we can't live like this. This is it's not healthy to do that. So we do put it away. We just can't find it after that. Wow, dude, this thing is going forever. 112-volt battery pack. Number one, Yanni, number one fan, man. Thank you. Wow, so smooth. I'm so happy that I did this. I mean, if we were to say make clips out of this live stream, it wouldn't be much to look at, but just this. But it's not too terrible, I got narrative going on. Yeah. Good. I hope everything's all right with the community and everything. Because there were some heated moments in the community, and I just hope everything, smooth itself out. And I'm talking about the creator community. And I just seriously hope everything's good. All right, Yanni. Thank you for the confirmation there. So yeah, I just wanted to show everybody the new rotor here and how well it's moving. And I'll think about making commutator plates to get either electricity or reading off of it. Yeah. And I hope that everybody's having a good day. I'm going to go relax for a little bit. Peace out. Have a wonderful day. Please subscribe. I might be back later. Bye now.